Mr. Chancellor, it is my pleasure to present to you Dr. Fabiola Gianotti, a distinguished scientist who has been a scientific leader in the collaborative, celebrated, and successful search for the Higgs boson. Dr. Gianotti recently finished her 4-year term as the democratically elected leader of a collaboration of thousands, including McGill physicists, operating what is, in essence, the most sensitively probing microscope ever invented, the Large Hadron Collider at CERN, the European Organization for Nuclear Research. Dr. Gianotti received her undergraduate degree in physics from the University of Milan while simultaneously training as a pianist at the Milan Conservatory. She received her PhD in 1989 for the University of Milan in experimental subnuclear physics, and in 1996 she became a permanent research physicist at CERN with prominent roles in high-energy physics experiments known by their acronyms, UA2, ALEPH, and particularly the ATLAS experiment. In her role as the ATLAS collaboration spokesperson, Dr. Gianotti presented the historic July 4th, 2012 seminar at CERN announcing the discovery of a new subatomic particle with properties consistent with those of the long-sought Higgs boson. Dr. Gianotti's career achievements have been acknowledged in the scientific community and beyond. For example, in 2012, she was awarded the Special Fundamental Physics Prize. In 2013, she received the Niels Bohr Institute Medal of Honor. She's been named one of Forbes magazine's top 100 world's most prominent women, powerful women. She's the only scientist on this list. And in 2012 was a finalist for Time magazine's Person of the Year, losing to Barack Obama, so no great shame. The conferral and acceptance of an honorary doctorate is a reflection of shared values of the deepest nature. As a world-renowned scientist and leader, Dr. Gianotti is an inspiring role model. Her new association with McGill makes us proud. More than this, as spokesperson for the ATLAS experiment, she shows us that the ego-challenging discipline of working together and collaboratively for a common cause with, as I said, thousands of collaborators can give rise to achievements which change our understanding of the world. Mr. Chancellor, I present to you Dr. Fabiola Gianotti, that you may confer upon her the degree of Doctor of Science honoris causa.
Thank you, Dean Grant. Ladies and gentlemen, I now invite Dr. Fabiola Gianotti to deliver the Convocation address.
Thank you very much, Chancellor Steinberg, Principal and Vice Chancellor Fortier, Dean Grant, distinguished guests, families, and young people, young graduates. I would like, first of all, to congratulate the young graduates on their superb accomplishment. This is your day. You are the heroes of the day. Bravo tout le monde. I must say that I'm extremely honored to receive this degree from such a prestigious university and to become part of the big McGill family. I had the chance over the past years to work with an excellent team of physicists from this university led by Professor Brigitte Vachon and Professor Andreas Warburton, who have been making very strong contributions to the Large Hadron Collider, to the Atlas project, and to the discovery of the Higgs boson. Il faut dire que c'est aussi assez agréable de recevoir un doctorat sans rien faire, ni examen, ni thèse, rien. Cool, quoi, c'était bien. More seriously, as you heard from Dean Grant, I am a particle physicist. Particle physicists study the ultimate, the most minuscule, the fundamental components of matter. And at the same time, the studies of the infinitely small allow us to understand the structure and evolution of the universe, so the very, very big. And to achieve our physics goals, we also have to develop cutting-edge technologies in various fields, superconducting magnets, cryogenic, instrumentation, computing, that then we transfer to society to the advantage of everyone's life. For instance, the World Wide Web was invented at CERN to facilitate the interaction among the scientists of the lab, and since then it has changed the way society accesses information. So with that, I would like to tell you that science and research are beautiful, they are sexy, but they are also useful. There is no progress without fundamental research. You always need a big step forward, a big idea. You need ingenuity. The light based on electricity is not just the evolution of the candle. It's not by building bigger and bigger candles and more colorful candles that you get the electric light. You need a big step forward. You need ideas. But I would like also to say that science in the broad sense, in the sense of knowledge encompassing many, many fields, not only mathematics, physics, but life science, literature, everything, are, with art, the highest expressions of human beings, as human beings, and they distinguish us from animals. So they have their important, great value and their dignity regardless of the application. What is the application of a Mozart sonata? None. But could we live without music? And I would like to bring in this occasion the words of someone who is much more wise than me. So a few years ago, a delegation from the US Congress visited a big laboratory in the US. Fermilab is a laboratory located in Illinois, and they are doing similar things we do at CERN, big laboratory with accelerators. And at the end of the visit, one of the congressmen asked the director of the laboratory, Robert Wilson, but how what you are doing here will affect the security of the country? And after thinking a few seconds, Robert Wilson replied, and I will read his words. What we do here in particle physics has nothing to do directly with defending our country, except that we help make it worth defending. Often people ask me, what are the main qualities of a scientist? And I reply, 3 things. First, curiosity and being hungry for knowledge. Ask yourself questions. Do not accept things as they are presented to you. Just go behind them, not to be negative or to criticize, but because you have to understand better. And let your mind go openly and explore different fields of knowledge. Second, modesty. And modesty for 2 reasons. First of all, because in spite of the huge progress that mankind has made in the centuries, today we know very little. Newton used to say, what we know is a droplet, what we don't know is an ocean. Today, we only know 4% of the universe. What we see out there, star, galaxy, planets, etc., they are only 4% of the universe. The rest, 96%, is dark. We don't know what it's made about. It's made of form of energy and matter that we don't know. So we need you. We need ideas to make progress. But also modesty, because only if we are modest, we can hope to improve and to give the best give the best of ourselves and to give more and to give better. We have also to keep in mind, however, while being modest, that the contribution that each of us can give is unique and special. I've been working, and I still work, in a collaboration of scientists, 3,000 scientists from all over the world. I can tell you that every one of them has made a crucial contribution to the experiment. We are 7 billion people on Earth, but we are all different. Our fingerprints are different, our personality is different, and the richness of mankind comes from diversity. And finally, the third quality is determination, perseverance, stubbornness. Don't give up in front of difficulties. No obstacle is insurmountable if you are animated by passion. Don't abandon your dreams. Don't let someone else abandon your dreams. And I think that these three qualities apply to everything in life, whether or not you are a scientist. I don't know what you will do in your future, and perhaps you don't know either. Some of you perhaps will go and teach. Some others will become scientists, researchers. Some others will work in industry. But I think that regardless of what you are going to do, remember that we can deprive us of everything. Money, house, food, clothes. But nobody can take away our brain. So, bon courage.